So have you ever done this? You've dropped some serious cache on a high-end server. We're talking tons of RAM, blazing fast NVMe drives, the whole 9 yards. And then you fire it up and its performance is just kind of meh. It's super frustrating, right? You've got all this horsepower, but it feels like you're driving with the handbrake on. So let's get into what's really going on here.
I mean, this is the question that drives system admins and, anyone who's a power user absolutely crazy. You did everything right, you bought the best gear on the market, so why is there this huge gap between what your hardware should be doing and what it's actually doing? Well, the answer is way simpler and honestly more surprising than you might think.
Yep, that's it right there. The bottleneck isn't some faulty piece of hardware. It's not a mistake you made during setup. It's the default settings of the Linux operating system itself. See, these defaults are designed to be incredibly safe, to be super compatible, to make sure Linux runs on literally millions of different devices, from ancient servers to tiny little computers. But that one-size-fits-all approach, it means your high-performance beast is basically being tuned for the weakest link.
Okay, so before we jump into how to unleash all that power, it's really important to understand why these defaults exist in the first place. This isn't some dumb mistake by the developers. It was a very, very deliberate choice. Let's break down the logic behind playing it so safe.
Look, it really boils down to three main reasons. First, they have to be conservative. The settings have to work on everything, from a 15-year-old spinning Rust hard drive to the absolute latest and greatest NVMe storage. Second, safety. These defaults prevent systems with barely any memory from just crashing and burning. And third, you've got to think about diversity. The perfect settings for a database getting hammered with traffic are going to be totally different from what you'd want on your personal desktop. The defaults, they have to be a compromise that works, well, okay-ish for everybody.
All right, let's get into the good stuff. How do we start optimizing? First up, the disk scheduler. The best way to think of this is like a traffic cop for your data. See, old hard drives were like these super complicated city intersections that needed a really clever cop to direct all the cars and prevent gridlock. But modern SSDs, they're like a massive multi-lane superhighway. A simpler traffic cop, or sometimes no cop at all, is way, way faster. The problem is, the default is often still that old, complex one.
Okay, next on the list is something called read ahead. This setting basically tells Linux how much data to grab ahead of time when you ask for a file. The default is like reading a book one single page at a time. It's safe, sure, but it's slow. But for things like big file transfers on a media server, you can tell it to grab a whole chapter in advance. This one tweak can be a total game changer and dramatically speed things up when you're working with huge files.
And then, of course, there's memory management. This is like the brain of the whole operation, deciding how to use all that fast RAM in your system to cache data so you can get to it quicker. But, you guessed it, the default brain is a little timid. If you have a server with a massive amount of RAM, the default settings are probably leaving a ton of that performance just sitting on the table because it's too scared to use it aggressively for caching.
So, okay, we've got all these conservative settings holding our awesome hardware hostage. Now, you could spend days, maybe weeks, tweaking dozens of these settings by hand. Or you could use a tool built by people who've already figured it all out. Let's meet the solution.
This is where this awesome open source script comes in. It's basically like having a senior system administrator bottled up in a script. It takes a look at your system and applies a whole set of proven performance-focused settings for your disk, your memory, and your network, and finally unlocks all that power you paid for.
Okay, hold on. Before you rush off and run this thing, we have to talk about the big, scary warning that comes right from the script's own documentation. This is serious stuff. We're talking about changing core system files and parameters, and if you misuse it, you could end up with a system that's unstable, or one that doesn't even boot. So yeah, this isn't something to take lightly.
But, and this is a huge but, the person who wrote this script, they knew how scary that sounds. So they built this tool from the ground up with that warning in mind, and they included a whole bunch of features designed to let you tune your system without the terror.
And honestly, the way they built in safety is just brilliant. Let me break it down for you. Before it touches a single thing, it automatically backs up your critical config files. It has a dry run mode, which is amazing because it shows you exactly what it would change without actually doing anything. It's smart enough to know if it's on a virtual machine, and it'll skip tweaks that might be risky there. And best of all, if anything goes wrong, there's a simple one-command restore function to put everything back exactly how it was.
And the best part? You're in the driver's seat. You get to choose your level. You can start with safe for some really solid, stable improvements. If you're feeling adventurous, you can go aggressive and really push the limits. And for the real pros out there, there's even a custom mode. You decide what kind of risk versus reward you're comfortable with.
And you're probably thinking this sounds complicated to set up, right? Nope, it's ridiculously simple. It's literally 3 commands you type into your terminal. You clone the project, you make the script executable, and then you run it. That's it. All that power, all that safety, made totally accessible.
Okay, so we've talked about the problem, the solution, the safety nets. But what's the bottom line? What do you actually get out of this? What kind of difference can these little tweaks really make in the real world?
We're not talking about a tiny 1 or 2% boost here. We are talking about a potential 20 to 50% increase in performance on the right kind of tasks. That is insane. That's like unlocking a massive chunk of your hardware's potential that was just sitting there, dormant this whole time.
But what does a number like that even mean? 20 to 50% can sound a bit abstract. What does that actually feel like when you're using the machine? Where would you notice that kind of speed boost?
This is where the rubber meets the road. For databases, it means you can handle way more transactions every second with lower latency. For file servers, you're going to see much, much faster transfer speeds for those big files. And for web servers and proxies, it means your site can handle a whole lot more visitors at once and won't fall over during a big traffic spike. These are real, tangible wins. So it all comes back to this one question for you. That default safe mode is great for making sure Linux runs everywhere. But if you're trying to run a high-performance server, that very same safety could be the one thing that's holding you back. So maybe it's time to ask yourself, is it time to take off the training wheels and see what your machine can really do?